In section 9.5, we're going to graph quadratic functions. Now, a quadratic function, as you may have remembered from studying the quadratic formula, is something that can be written in this form, where there's a number times x squared plus another number times x plus another number. The key is that the highest exponent is 2. The highest power of your variable x is 2. Now, to give us a basic idea of what these graphs are going to look like, we're going to start with the function f of x equals x squared. And we're going to graph it by making a table of points, where we're going to plug in values for x and see what we would get for the function. And a lot of times, if you're not sure what values to pick, it's good to pick values that are right around the center of the graph horizontally. So I'm going to pick -2, -1, then 0, which is right in the middle, and 1 and 2. Usually using these 5 numbers will give you an idea of what's happening near the middle of your axis there. So if we put in -2, -2, when you square it, would be -2 times -2, which would be a +4. So that tells us that the point -2, 4 is on our graph. -2 for x and 4 for y. When we plug in -1, -1 times -1 is a +1. So the point -1, 1 is on our graph. When we plug in 0, we get 0, 0, because 0 squared is 0. So that's right there at the origin. When we plug in 1, 1 squared is 1. So we have the point 1, 1 on our graph. When we plug in 2, 2 squared, 2 times 2 is 4. So the point 2, 4 is on our graph. So the first thing you'll notice is this is not a straight line. It's a curve. And the curve starts pretty high on one side. It goes through all of these points and then goes up on the other side, like that. This type of curve, which is going to be the kind of curve you get for any graph of a quadratic function, is what we call a parabola. So graphs of quadratic functions are parabolas, like that. Now, what we're going to do in this section, the keys are going to be finding the vertex, which is the point right at the tip. In the case of that one, our vertex was right at the origin. And then we're also going to find the X-intercepts and the Y-intercepts. So to do that, there's some formulas here that'll help to remember. The vertex of one of these quadratic functions, to find the x value, you have this short little formula. One thing you might notice about this little formula, it's the same thing as the quadratic formula we learned earlier, just without the square root. It's -b, but instead of the plus or minus square root, that's all you have on the top. -b over 2a. Now you use that formula to get the x value of the vertex. To find the y value of the vertex, you'll take the result of that formula and plug it back into the original function. You'll see what I mean when we do that in just a moment. Next, to find the x-intercepts of a function, you plug in 0 for f of x. In other words, you take your whole function and you set the whole function equal to 0. And then you're going to try to solve it, whether by factoring or using the quadratic formula to work it out. And then last, to find the y-intercepts, you plug in 0 for x. And you'll notice if you do that, you're going to get 0 here, 0 here. You're going to have 0 plus 0 plus c. In other words, the y-intercept is c, the constant term of the function. So keeping these 3 things in mind, let's take a look at some example problems. We're going to start by looking at this function f of x equals x squared minus 4x minus 5. We're going to find the vertex, the x-intercepts, the y-intercept, and the graph of the function. So first, looking at this function and working on finding the vertex. To find the x value, we use that opposite of b over 2a formula. So we have the negative of, and then b in this case is -4. So the negative of -4 on top. On the bottom you have 2 times a, and since it's just x squared, remember that's the same thing as 1x squared. So a is 1. The negative of -4 is +4. 2 times 1 is 2, and 4 divided by 2 is 2. So we know that the x value of our vertex is 2. We still have to figure out what the y value is. To do that, we're going to plug 2 in for x in the original function. So instead of x squared, we have 2 squared. Instead of -4x, we have -4 times 2, and then we have -5. So this would be 4 minus 8 minus 5. We end up with -9, like that. So 2, -9 is our vertex. Next, let's work on the X-Intercepts. To find the X-Intercepts, you set the whole function equal to 0, and then see if you can solve it. So here we have x squared minus 4x minus 5 equals 0. Now this is one that we can solve by factoring. Remember, when you factor one of these trinomials, since it starts with just 1x squared, we know we're going to put x at the beginning of each group. And now we have to think, what can we multiply to get -5 that adds up to -4? And that would be a -5 and a +1, like that. And then to finish it, you set each one of those factors equal to 0. X minus 5 equals 0. X plus 1 equals 0. You end up with x equals 5 and x equals -1. So that tells us the x-intercepts, remember, are the points where the graph crosses the x-axis. So this graph is going to cross the x-axis at +5 and at -1. And last, let's do the y-intercept. Well, the y-intercept is just the constant term. And since it's a -5, our y-intercept is -5. And remember, y-intercept goes on the y-axis. So, keeping all this in mind, let's put all this together on our graph. So we have that our vertex is the point 2, -9. So 2 to the right, down 9. Our vertex is right there. Our x-intercepts, which are the points where the graph crosses the x-axis, are at +5 and -1. And last, our y-intercept is at -5, which is right here. So keeping in mind that our vertex is that point down at the bottom, to graph this function, we'll start up on the left, curve down through those points, up through that last point, like so. And that's it. That's what our graph would look like. Let's try one more example here. Here we've got the function f of x equals 2x squared plus 2x plus 5. So focusing on that one, let's go through our steps. First, for finding the vertex. Finding the vertex, we use our minus b over 2a formula. So in other words, it's always, when you're finding the vertex, going to start out like this. You just plug b into that parentheses on top, a into that parentheses on the bottom. Here, b is a +2. A is also a +2. So on the top of the fraction, we have -2. On the bottom of the fraction, we have 4. I like decimals more than fractions, so I'm going to go ahead and change that to a decimal. It'll be -0.5. And then remember, to get the y value of the vertex, we take that and plug it back in. So here, instead of 2x squared, you have 2 times negative 0.5 squared. Instead of 2x, we have 2 times negative 0.5, and then plus 5. Now, a lot of students make a mistake on problems like this. The next thing you need to do is square that parentheses that's being squared. You always take care of exponents before you multiply in the order of operations. So if you do negative 0.5 times negative 0.5, you would end up with a positive 0.25. And everything else for right now stays the same. Then you do the multiplying. 2 times 0.25 is 0.5. 2 times negative 0.5 is negative 1. And then we have plus 5. And all of that works out to 4.5. So the x value of our vertex is negative 0.5. The y value of our vertex is 4.5. Let's go ahead and put that on our graph. It's going to be half a space to the left for x and up 4.5 spaces. So if we go from the origin half a spot to the left and then up 1, 2, 3, 4.5 spaces, our vertex on this graph ends up right in the middle of that box there. Half a spot to the left, up 4.5 spots. Okay. All right. Now let's do the next step, finding the X-Intercepts. To find the X-Intercepts, we want to set this whole function equal to 0. So 2x squared plus 2x plus 5 equals 0. Looking at that, honestly, a lot of times when there's a number in front of the x squared, I just use the quadratic formula anyway because the factoring's so difficult. I don't think factoring's even possible on this one. So let's solve this one using the quadratic formula, which, just as a reminder, is negative b plus or minus the square root of b squared minus 4ac over 2a. So we have negative plus or minus square root a number squared minus 4 times one number times another number, all that over 2 times a number. Now for this equation, a is 2. So everywhere that there's an a in the formula, we put a 2. B is also 2. So everywhere there's a b in the formula, we put a 2. C is 5. So we put a 5 in the formula for C. So now if we keep going, we would have negative 2 plus or minus, and we do all our squaring and multiplying. 2 squared is 4. Negative 4 times 2 times 5 is minus 40. On the bottom, 2 times 2 is 4. Next, we subtract those numbers under the square root, and we get negative 2 plus or minus the square root of negative 36 over 4. And here we have a problem. When you're dealing with real numbers like we are in this class, you can't take the square root of negative numbers. It's not a real number for the answer. So here we can stop and say there's no X-intercept. And the reason we know that is because there was a negative sign under the square root when we tried to solve it using the quadratic formula. That means there's no answer to this equation, and that means there is no X-intercept for this problem. So let's do the last part of this problem, which is finding the Y-intercept. The Y-intercept, remember, is your constant term, which in this case is a plus 5. So our Y-intercept is a positive 5. What that tells us about the graph is that we're going to have a point at positive 5 on the y-axis. Now here, it's important to notice that to graph a parabola, you have to have at least 3 points. we've only got 2 right now, and we need to get a third. Here, what we can do is we can use the fact that when you look at a parabola, it's symmetric on the left and right sides of the vertex. For example, if we look at that previous graph, this line right here, x equals 2, would be what sometimes is called the axis of symmetry. And when you have a point, say up here, 3 spots to the left, at that same height, you'll be 3 spots to the right. This point here that was 2 spots to the left, you're going to have a point 2 spots to the right. So it's symmetric horizontally, like that. So keeping that in mind, if we use the fact that on our current graph, we have a vertex right here and a point right here, we're going to have another point at that same height on the other side of the vertex, right here. So knowing that, using the symmetry to get our third point that we need, we can draw a curve that goes through those 3 points of the vertex. You can also, if you're finding this idea of symmetry confusing, you can also just plug in -1 to see what the y value would be at that point. And if you plug in -1 to the function, you would end up getting 5.